Use the given degree of confidence and sample data to construct a confidence interval for the population mean mu. Assume that the population has a normal distribution. Okay, so here it's asking for estimation of the population mean. And because it's asking for the confidence interval, you need the margin of error. And there are different formulas for margin of error. For example, you have something like E equals to Z alpha over 2, square root of PQ over N. That's when you have population proportion and you're trying to estimate that. That's the margin of error in that case. Well, here it's not trying to estimate the population proportion. We're trying to estimate the population mean. So we use the formula Z alpha over 2 and then sigma over square root of N. Except there are a few exceptions. If your sample size is less than 30, but if number one, if sample size is less than 30, and number two, the population standard deviation is not known, then you must use the t-distribution. Okay, so let's use the t-distribution to solve this. First of all, let's calculate t alpha over 2. By t-distribution, it's the same formula except that you have t alpha over 2. And also, because you don't have sigma, you use the sample standard deviation with Bessel corrected. So usually when you're given this, it's already Bessel corrected. So this is the Bessel corrected sample standard deviation, and you divide that by square root of n. So I mean that you have to divide s over square root of n. And a lot of times people write s sub x. At least that's what your calculator does. So that's the formula that we have to use. Okay. That means we have to figure out what t alpha over 2 is, and the procedure is, first you say alpha is equal to 1 minus 0.99, because the significance level, alpha, is defined as 1 minus the confidence level, so 0.01. And then t alpha over 2 would be inverse t function with 1 minus 0.01 divided by 2. So let's use the calculator to figure that out. Clear, and then we have second vars, go to inverse t, and you want to put in 1 minus 0.01 divided by 2. Oh, but then it's asking for degree of freedom. Well, degree of freedom for t-distribution is always the sample size minus 1. So we put 11 for it. Okay, we paste and we get the value of 3.106. Okay, so that's 3.106, and note that degrees of freedom is defined as n minus 1, and because n is 12, it's 12 minus 1, which is 11. That's how I put this value was needed in order to calculate this fully. Okay, so so this was needed in order to get that. Now the important thing is we got the 3.106, and now we have to calculate the margin of error using this formula right here. So we have 3.106 as t alpha over 2 times the sample standard deviation is 4.8, and divided by the square root of n, and that's 12. Let's again use the calculator to calculate that. 3.106 times 4.8 divided by the square root of 12, enter, and you get 4.304. 4.304. And then, well, you know, because your sample standard deviation ends at the tenths, let's just use 4.3. Okay, and then the confidence interval would be the sample mean plus or minus. I think there should be a bar here. They forgot to do that. Now you just have to do 28.3 minus 4.3, and the actual population mean is between this value and 28.3 plus 4.3. So the confidence interval is 24.0 mu until 32.6. That will be the confidence interval.